We work with our international counterparts, and not just those that are in North America and in Europe. We also work with a whole variety of partners all across the globe, including Global South, which is one of the main reasons why I'm here. We also work with the academic sector as well, so universities, research centers, think tanks, and we also work with just the general public as well, because actually, ultimately, the end users of cyber products, digital products, are the public, and they need to be informed about what we're doing, and we need to be aware about what issues are coming up when they're using technologies. And it should be said, this relationship, it's not a linear relationship. It's not just us providing that advice to all these different stakeholders. These stakeholders are providing advice to us as well. We are getting information from them so that we can provide the best possible advice so that it's practical and realistic. So in terms of actually what we do, we work to understand the evolving cyber threats. We develop cybersecurity mitigations and publish advice and guidance. And we reduce risk by securing and improving the resilience of both public and private networks. And if all goes wrong, if it all goes Pete Tong, as you would say in the UK, we also help to respond to significant cybersecurity incidents as well. So, in terms of technical standards, because this is what this kind of presentation is going to be kind of really focusing in terms of the work we've been doing to develop a technical standard. For those that don't know technical standards, because not many people do, it's quite a niche area, I will try my best to explain what a technical standard is. Ironically, there is no standard in how a standard should look. Standards can look in a variety of different ways, and they are developed in a variety of different ways. But in a very basic way of explaining it, a standard describes a good practice in how something, a technology, piece of software, some sort of digital technology, usually, of how they are designed and developed and deployed when being used. So standards are useful for compatibility and interoperability reasons. It's the reason why we can call to different network operators. It's the reason why we can make phone calls to different countries. It's the reason why our phones work in different countries, admittedly, usually at higher cost. But the fact is that they actually do work. And it's the same across all digital services, all across the internet. Everything works purely because different companies that have different IP and different technologies all are working together using standards. So that is the fundamental reason why standards are actually good. They provide that underpinning. They also accelerate innovation. And then why I particularly care about it from a kind of a cybersecurity perspective is that they actually ensure that products and services are performing safely and securely, providing at least the minimum baseline security standards that we would expect to keep users secure. So standards are mainly developed through an industry-led multi-stakeholder process based on consensus, openness, and transparency. And then they are usually, not always admittedly, but they are usually developed in what is called standards development organizations, SDOs, or you could just call them standards bodies themselves. And so these are these are a small handful of standards bodies or SDOs that we work in. The ones on this graphic here are the ones that we from UK government typically tend to engage in. It is a proper alphabet soup. There is lots of acronyms there, and it can be quite complex. They all do slightly different things. They all work slightly differently. The standards bodies highlighted in yellow are the ones that we in UK government typically work in. So there's ISO. ISO is probably the one that is very well known to most people. If you have a fairly basic understanding of how standards work, ISO is the one that you might recognize. That's the International Standards Organization, or maybe International Organization on Standards, I think technically. How that operates is every country has a national standards body. In the UK, it is the British Standards Institute, BSI. And you form a delegation, a group from your own country, and you develop standards within your own kind of country, and then you take that up to ISO, and then it is agreed on a consensus base across different nations. There is also the ITU, International Telecommunications Union. That is a UN-based standards body, so it's attached to the UN. The ITU is very different if you compare it to other standards bodies, where the delegations, the work, is led by governments. Where different standards bodies, it is led by industry. Industry are the one who are developing the standards, where government is supporting. In other standards bodies, where the ITU, it works the other way around, where governments are leading the development of those standards with industry supporting. We also do work in those other yellow boxes, so ETSI, which specializes in information, ICT and telecom standards. That is where their real speciality is. They're industry-led, and they are based, the standards body itself is based in the south of France, but they produce global standards, but they specialize on ICT and telecom standards, and we do a lot of work there. There's also 3GPP, which stands for the Third Generation Partnership Project. Can't remember what the last P stands for now, but essentially they specialize in mobile standards. So 3G, 4G, 5G, and then 6G or whatever 6G is going to be called, whether it's future telecoms or whatever it's going to be called. But they specialize in that particular area. W3C, the World Wide Web Consortium, they specialize in World Wide Web standards. IETF is the Internet Engineering Task Force, and they specialize in internet standards, internet protocols, internet governance, the whole formation of how the internet is run. Those particular organizations, those standards bodies, we do a lot of work in. They all work very differently, as I say, and they all have their different pros and cons, I should say, as to how you kind of work in them, how you get the results, how you actually develop the standards that are good quality, but then also improving whatever it is that you want to improve. For us, it's cybersecurity. In terms of the actual different technology areas that we do in these different standards bodies, I've got them on the board there, but telecommunications, all the kind of telecommunications security you can imagine, quantum technologies as well, and then that also includes post-quantum cryptography. We do a lot of work on PQC, and I'm doing a talk tomorrow as well. I'm doing a panel on PQC tomorrow as well. We also do semiconductors, AI, obviously, and I'll talk about that in a little bit more detail in a minute, and then obviously the internet as well. How do we secure the internet? And that is itself, just very quickly, in terms of how you secure the internet, that is a very politically difficult subject as well, because everyone wants privacy, but then there's also about how do you ensure that you get privacy whilst ensuring that bad people aren't doing bad things online, on the internet. And that is a debate that every single country, government has with every other government, but also how governments also have difficult conversations with the private sector. There are some technology companies, usually US-based companies, who have a different view. To put it politely, they have a different view to how maybe some governments have it. And that is those forums, particularly the IETF on the internet, it's a good forum to have that debate and actually come to a reasonable compromise on how you handle standards like that. So, just very quickly, it should be said, I'm not an AI technical specialist. I understand this at a good level, but my bread and butter, my specialism is on standards, not on AI. So if you have particular questions at the end, which hopefully there will be time, please don't ask me too harder AI technical questions. So in terms of just the cyber threats to AI systems, I'm not going to be able to list them all, in part because there's quite a few, and in part we're actually still learning more and more as the technology is developing. We're learning more and more different cyber threats. But here's a handful of different threats that are specialists to AI systems that I just kind of want to bring out in a little bit more detail. So it should be said that the traditional cyber threats to software apply pretty much applicably to AI systems. It is still a software. So those different threats and therefore the security measures need to be put in place. Those traditional cybersecurity methods need to be put in place as well. However, with AI, there are some unique things as well. So in terms of, so one particular threat are adversarial inputs. And so those are maliciously crafted data designed to trick AI models into producing incorrect or harmful outputs. There's also data poisoning, which is the insertion of corrupted or malicious data into training sets to compromise model integrity. There is model inversion and membership inference. So these are attacks that extract sensitive information about training data from model outputs. And then there's indirect prompt injection, which is very well known about, but that's exploiting input prompts to override system rules or produce unintended outputs. So those are some of the more very specific threats to AI that is not very well, there is less information on actually how do you mitigate those particular threats, which is where UK government stepped in to kind of try to solve this, to try to give good information on how to mitigate those particular threats and to give good advice on how you can practically do it. So our main goal was to address those cyber security risks to AI. As I said, we are still learning more threats and risks to AI, but it's what we can focus on now that we're aware of, and then any further particular risks or threats that kind of unfold over the coming years, we will just have to adapt and continue to provide more updated advice. But the work we wanted to do was to target all AI systems. There are so many out there, but this is about including the different models, the different tools, the different technologies that AI systems rely on. And we also wanted to target the entire life cycle of AI. There's quite a lot written already about how you protect the kind of the development, the deployment, and the kind of the operation of the AI system, but there is very little, if any, really, or any good advice out there on how you then decommission the AI system. How do you retire it? How do you kill it? And then we also wanted to focus on the entire AI supply chain, with particular focus on the developers and deployers for obvious reasons, because they are the ones who are ultimately responsible on how you kind of build and maintain an AI system. But actually, it was going further than that. It was going for the entire supply chain of AI. My thing has frozen. My slides have seemingly frozen. Sorry. Technical issue. Yeah. 30-second pause whilst we just resolve it. Yeah. Yeah. Just as we're waiting, oh, there we go, it's starting to move. As we're waiting, though, out of interest, just by show of hands, who understands standards? Are there people out there that work on technical standards here? Just trying to understand the kind of the baseline knowledge of the audience here. It's okay. No one particularly has a full grasp of standards. That's great. That's not an issue at all. I just understand the kind of the level I need to pitch at here. So, yeah. Yeah. So, I'm skipping ahead here a bit, and I will go back, but I wanted to show this. This is a really important slide. This is ultimately what we landed on in terms of the best advice to secure your AI systems based on those threats and risks that I just outlined on that previous slide. So we put across 13 principles across 5 phases of the AI lifecycle, setting minimum or baseline security requirements. Okay? Now this is baseline. You could go further. However, from our perspective is that we want as many organizations at whatever level you have to meet these requirements. To be honest, we want people to go further, but actually sometimes that is just not practically possible. It's too much money, it takes up too much time. You're maybe not a business that necessarily has those resources to do. But this will, at the very least, provide you those good baseline security requirements. So if I just quickly just run through those principles. So it should be said there are a number of provisions, obviously. I'm not going to go through every provision because I'll be here like the entire day. But there are a number of provisions within these particular principles. Some of these provisions are mandatory and some are voluntary. And what that actually means, when I say mandatory provisions, it's when you read it on the technical standard, it's you shall do this, you shall do that. That's mandatory. Voluntary is you should do this, you should do that. So that is very much this is what is essential, and this is what is ideal, preferential. So in terms of the actual the principles themselves, so the first life cycle, design. First principle within that is raise awareness of AI security threats and risks. Principle 2, design your AI system for security as well as functionality and performance. Principle 3, evaluate the threats and manage the risks to your AI system. Principle 4, enable human responsibility for AI systems. We then go on to phase 2, development, which is identify, track, and protect your assets. Principle 6, secure your infrastructure. Principle 7, secure your supply chain. Principle 8, document your data, models, and prompts. Principle 9, conduct appropriate testing and evaluation. And then on to the deployment phase. There are provisions under the principle conduct appropriate testing and evaluation because there are overlaps there. And then also principle 10, communication and processes associated with end users and affected entities. And then on the 4th phase, maintenance phase, again, there are provisions within principle 10, communication and processes associated with end users and affected entities. Principle 11, maintain regular security updates, patches and mitigations. And principle 12, monitor your system's behavior. And then the final phase, end of life, there is one principle of ensure proper data and model disposal. Now, as I said, there is less information out there. There's less research out there on that final phase. That is why there is only one principle out there at the moment. Obviously, a number of provisions within that principle, but there's one principle. We are hoping that over the coming months and years that there's going to be much more research, practical and theoretical, to actually inform that even more. And we are planning on reviewing this particular work over the coming year or so anyway, to update it on both the end of life area, but then all the other phases, to be honest with you. But essentially, these particular principles are what we see as the best way to protect your systems that are also practical as well. So in terms of the evolution of the work, there's one thing me saying, this is what we think, but actually, what's the credibility behind that, In terms of the actual evolution of the work and how why we are confident that this is good. It's not just because it was written by some clever people within the UK government. It was written by and supported by clever people throughout the world in various different organizations that kind of have different interests in this area. So in terms of the actual first thing that we did was the UK National Cybersecurity Centre developed the guidelines for secure AI system development. This was I think about 2.5 years ago now that they were developed. Roughly in time for the first AI summit, the one that was in the UK at Bletchley Park. So it's quite nice actually that I'm now talking about it, you know, at the Delhi AI Impact Summit. But this was a first attempt of providing those security guidelines on how to develop AI systems. It was done in collaboration with the Cybersecurity and Infrastructure Security Agency, CISA, which is a part of the US government. But we also did it in collaboration with 20 other cybersecurity agencies across the world: North America, Europe, Asia, Africa, and South America. So it went across various different organizations. It also had some level of industry consultation as well. They didn't necessarily write it, but there was a level of consultation. Our main intention for this was to kind of firstly understand, what do governments think of from a cybersecurity of AI perspective. Then, once that was published, the UK Department for Science, Innovation and Technology took the guidelines along with some other material out there and produced a draft code of practice. This draft code of practice went out for public global consultation. We purposely advertised and promoted this particular code of practice consultation to ensure that we could get as many voices as possible from throughout governments, industry, the public, big companies, small companies, whatever, trying to get their feedback. The consultation, I think, ran for about 4 months or so, and we received hundreds of we received hundreds of feedback comments. Hundreds of stakeholders fed into the consultation. The overwhelming majority supported the work or supported the actual advice within the draft code of practice, but there were naturally things that needed to be amended. And so we went through all those different comments and took them on board. And then finally, the code of practice was then published as a final document. We then took that code of practice, because we knew that a UK code of practice doesn't necessarily mean that it will get picked up globally. You know, it's had global input. Doesn't mean that someone looking at a UK code of practice will necessarily think, this is good. You know, if you're based in India, if you're based in Nigeria, you're based in France, wherever, will you necessarily think, I want to implement this? So we then took the code of practice to ETSI, and I talked about ETSI earlier. For those that don't know, ETSI stands for the European Telecommunications Standards Institute. It's a standards body. Don't be put off by the fact that ETSI begins with European. It is a global standards body. It develops global standards. It has global membership. I wish that they would actually change it from European, because I think a lot of people assume that they only produce European standards and only by European partners, and that is not true at all. There are plenty of standards out there that ETSI have developed that are adopted across the world. But we took it to ETSI, and we first developed it as a technical specification. And one of the main there are several reasons why we took it to ETSI. In part because from UK government, we know ETSI. We know that they are really good at both the AI side and the cybersecurity side. They are really good at they're really good standards professionals. The other reason is we knew that they could, through this process, develop a standard reasonably quickly. Anyone that works on standards, a standard could take 4 or 5 years to develop. And that just simply, in some circumstances, is just way too long. The market, industry, the market, are crying out for a standard of some sort to be produced, some sort of advice. But waiting 4 or 5 years is A, too long, and B, by then there are new kind of cyber risks out there and it's all kind of outdated. We knew that through this particular process that I'm running through now, we could develop a standard reasonably quickly, but not at the cost of the quality of the standard. Because there is a risk if you develop a standard too quickly, it's just poor quality. But we were confident in this particular process to make sure that the quality continued. The other reason why we went with Etsy is that they produce free standards. All those other standards bodies that I mentioned do produce free standards as well. 3GPP, W3C, all that produce free standards, apart from ISO. So the one that everyone knows about, ISO, and they produce really good standards, it should be said. Anyone that works on ISO, they produce good standards. It's just that you have to pay for those standards. And our perspective is that standards should be free. They should be available to anyone, whether you're a big company with billions of dollars, or whether you're a small company or just a person in their basement. They should be available to everyone. This is good cybersecurity practices that should be available to everyone, and people should have that level of support to ensure that their technologies, their IP is being protected. So that's why we went with Etsy, rather than kind of ISO. It should be said that we are still supporting work, similar work going on in ISO in relation to this work as well. So yeah, so we developed we took it through the Etsy Technical Committee on Securing AI, and we worked with those particular individuals there, those standards professionals, to ensure that the standard was how it should be. It had all the kind of relevant security requirements in there. And then we then decided to upgrade the standard from a technical specification, a TS, as you can see on there, TS 104223, to EN 304223. Now, I won't get too technical on this. In reality, that doesn't really change anything particularly. The advice, the actual content within the TS and the EN is pretty much exactly the same. The only reason why we upgrade it to an EN, well, there are two reasons, sorry. The first reason is that it provided additional consultation with the standards body Senelec, which is a European standards body. So it's good to get further views on actually, are we taking on board all the relevant information out there? Are we referencing all the other kind of international frameworks that are out there? And then the other reason is so that it could meet the requirements within the EU AI Act. Now, I'll be honest, I don't know every single requirement within the EU AI Act, and I probably wouldn't expect you guys either to necessarily know it. But essentially, any company, wherever in the world, that operates in the EU market is strongly encouraged to adopt EN standards. So that is one of the reasons why we went and upgraded to an EN, was to ensure that the standard itself could be adopted by various different global companies who are operating in the EU, and they can say, yes, we are definitely meeting requirements within the EU AI Act. Now, companies that are operating outside the EU, you can choose to adopt the TS or the EN. It doesn't really matter. The actual content is exactly the same. So the actual and how you kind of then implement it, it doesn't actually matter whether it's the TS or the EN. So this process, how these particular requirements were put together, were tested several times across various different organizations, hundreds of organizations across the globe. We managed to get comments from every single continent, minus Antarctica, obviously. We're not going after the penguins in Antarctica. But every part of the globe was collaborated with, was consulted with as part of this. And as I say, across that multi-stakeholder, across different governments, across industry, academia, big companies, small companies, cybersecurity experts, AI experts, standards professionals. And that is how we then ended up with the the final product and those particular security provisions. So in terms of supporting documentation, so on the left of that slide there, obviously you've got the EN I talked about, the EN 304223, that provide those security requirements. There is also, and everyone loves a good reference number, TR 104128. That's Technical Report 104128. That is also freely available on the ETSI website. Again, similar route of how we produced that particular technical report. Lots of consultation. In part, it kind of was part of this consultation, and then we ended up splitting out some of the work, so focusing on the security requirements and then bringing an implementation guide and in a separate document just for ease. But essentially, we produced an implementation guide. What that essentially is a practical way of different companies that are running different AI systems on how they can actually implement the different requirements. So whether it's whether you run like a chatbot AI app, or a kind of ML fraud detection system, or a kind of you're an LLM provider, or you're an open access LLM. There are different examples and individual kind of use cases on how you implement the different security provisions, because obviously different AI systems work differently, and therefore the requirements require a slightly more tailored advice on how you implement it. How do you secure your systems based on that? And then it's all mapped to existing international frameworks and other kind of standards that are out there that might have a link to that. And then we are currently working on a conformity assessment. It'll be, once it's published, it'll be TS 104216. What this essentially means is that once it's published, and again, this will all be free as well, it's a way for different companies to assess on actually how are they meeting. Are they meeting, and how are they meeting the different security requirements within their own AI system? And because often you need that conformity assessment either because your company requires it, or there are certain regulations in place based on whichever country you're in that require a level of conformance, and you need to prove that assessment there. Let me just go back on this here. So all these documents here are there to support the actual work of this particular of these particular security provisions, and this is how we ended up developing a standard within a couple of years or so, using the multi-stakeholder framework, driven by the UK government, but not led by us. We were very conscious of not coming across as we were leading this. This is our advice. It's in part our advice, but also it is in part, or more so, other people's advice, but just us as UK government providing that kind of that drive through the different organisations that we took it through. So yeah, that's my presentation. I guess, are there any particular questions or comments that people have? I can see one at the back there.
Yeah, myself, I'm Prashant. I'm from State Bank of India. You said that 13 principles are there, and there are certain principles which should be considered as mandatory.
Sorry, I didn't get that. I can't hear very well, probably because the microphones are facing that way, or the speakers are facing that way.
Yeah, 13 principles you have explained.
Yes.
In those 13 principles, what are the principles can be considered mandatory?
Which ones are mandatory?
Yeah, which you consider as mandatory. That's what.
So there are different. It should be said, I didn't say this at the beginning, but a standard is a voluntary thing. We in UK government, we strongly encourage companies to adopt standards, but we think they are better when voluntary. Now, doesn't mean that every single standard should be voluntary. Some are form the basis of regulation, and different governments do that. So just firstly, just that kind of very kind of high level standards are voluntary. In terms of the actual principles, it depends on which provisions within the principles. So different provisions are mandatory within the different principles, and some are more voluntary. So, as I said earlier, there might be some kind of, you shall do X, you shall do Y. So those are within different provisions, and then there's the you should do X, you should do Y, which are voluntary. I'll be honest, I don't know off the top of my head which provisions are mandatory and which ones are voluntary. But you can look on the standards, and I do strongly encourage you to look at it. But there was a lot of debate within the ETSI group as to which ones should be considered mandatory and which ones should be considered kind of voluntary provisions, and it led to a couple of days of pretty heated debate. And this is standards here we're talking about. We're all quite calm people, but there were lots of conversations about what should we be saying to people. This is essential to practice systems, and this is voluntary. Did that answer your question? Sorry.
Okay, it will take time then. For abstract principles, it will take time. What? For mandatory?
Sorry. Could you say that again? Sorry.
What you are telling that the principles, what you are telling, you have told that they are not abstract in nature right now.
Yeah.
Okay.
Yeah.
They should be formed.
Yeah.
Okay, thank you.
Yeah. Okay.
So my question, yesterday I attended a session where this session was chaired by EY, Ernst & Young, and in that session there was one participant from Singapore, I think probably Singapore government, where I'll just let you know the session, Effective AI Assessment, Verification and Assurance, Establishing the Foundations for Responsible Confidence in AI. Okay. In which one of the note I made was that they have published AI Verify function by Singapore government, a set of harness where you can run your AI developed whatever software you call. Yeah. So you can run through those harness and at least get some sort of level of confidence that they're covered. I'm not sure those are in sync with your standards. I'm not sure about that. But my question, to be very specific, is when you are having a standard, is there a harness where we can run through that harness and say that okay, it is complying with certain set of standards, rather than just going through the document and then we building our own harness and interpreting the. Yeah. Since it's a very new field, probably there's a lot of interpretation risks are there. Yes. With respect to standard.
Yeah, well, thank you for letting me know about that. I'll check it out. And I will admit there is lots of information out there, and there are different standards out there that are on cybersecurity, but that are on a different tangent of this. So there's work going on in ISO, which is what we see as complementary to this, which is why we're supporting some of the work going on in ISO as well. So like, I'm not familiar with the work you just mentioned, but I'll check it out and see. In terms of how you meet it, that hopefully will be easier to kind of explain once the conformance assessment is published. The implementation guide provides those different examples, as I said, on how you can meet it under different terms, but the conformance assessment itself will be able to kind of tell you whether you are meeting it and how you're meeting it. That's the only way you can kind of do it at the moment anyway. We are considering different ways of how that comes across as well, whether it's kind of self-assessment or whether it's independent or like third-party assessment as well. So that's all that's all part of our thinking as well, as to making sure that those companies not just have the right advice, but are also checking to make sure they are doing the right thing. And there are pros and cons to both of those. But yeah, that's probably the best way, I think. And we're hoping the conformity assessment will be out in a few months or so. Yeah.
Hi, my name is Ishita. So I have a bit of a general question. So in the 13 principles that were listed, yeah, so there are some points about monitoring the system's behavior and assessing the threats. So so AI being such a emerging field, and the models that we have today are themselves showing an emergent behavior, so it's a bit difficult to predict what kind of behavior we are going to see in future. So how do we make sure that the standards are not catching up with AI, but rather are they they're in pace with the development in the AI field in general?
Yeah, and it's a great question. I think, as I said, standards can take a long time to develop. I think that's okay in most cases, most technologies, because kind of with other technologies, there are developments, but they're all kind of fairly steady for the most part. AI is, as you say, one of those technologies that just, at least in these last few years, I know AI has been going on for decades. You talk to AI experts, people say AI has been going on for decades. But last few years, particularly with the amount of investment and the amount we are seeing both being used publicly and just within the AI industry itself, new things are cropping up, new ways of actually how you use AI. You know, there's agentic AI, there's artificial general intelligence, AGI as well, and those are different elements of AI. So because of that, there are new things coming up, and you're totally right. And there are probably areas where we would want to do more work on this, and that is exactly why we are looking to update this standard in a year or two. We're not quite sure when is the best time to do it, and in part we're thinking that actually sometimes it might be better to actually, rather than update the standards in its entirety, it might be better to support the work of other standards bodies or kind of other governments or industry-led initiatives to provide kind of advice that kind of is almost like an annex, like an unofficial annex to this, to provide that kind of more updated advice based on, changes in the technology or just increased knowledge on the different risks and threats that are out there. So it's not. I know it's not a great answer, but it's we want to do as much as we can, but standards inevitably take a long time to develop. But the industry and the end users, us as consumers, expect those particular systems to run securely. So that's the balance that we're trying to meet at the moment. So as I say, we want to review this in a year or two, when there's a bit more research and information out there. But in the meantime, provide some support and assistance to AI companies or other standards bodies or different governments on making sure that information, or the updated kind of security information, is given to the public and given to the industry.
Hello.
Hello.
My name is Bridget. I work with an organization called Paradigm Initiative, and I see the 13th principle highlights proper data and model disposal, but I'm keen to know how all of the principles reflect on issues of data minimization, especially in an era where data is often extracted without the necessary safeguards, or also without the necessary consultation from specific communities or vulnerable communities. And also one of the other principles also highlights testing and evaluation, and I'm keen to know how principles of concerning issues around oversight are being taken into account. I know testing may involve regulatory sandboxes, but what oversight mechanisms are in place for such an output that you've developed? Thanks.
Yeah. Really good questions. So I'll take the oversight one first. So the standard itself does outline specific roles and requirements of the different stakeholders. You know, whether you're a kind of data custodian or kind of some sort of AI developer. So the standard itself provides the not just the terminology, but the actual responsibilities of different stakeholders, different kind of AI developers and deployers within an organization about what you should be doing as a developer, as a deployer of AI. It's never, you can't get it perfect because every company will have a different structure. You know, big companies will have different levels of staff working on developing and maintaining their AI systems versus like a small company, for example. But the actual standard itself does provide a sort of a level of guidance on what different roles and responsibilities and requirements those different roles within a company should have to maintain, you know, data security or data integrity as well. Your first question, I'm just trying to remember what your first question was again. It was data minimization. Yeah, that's it. So the standard, from memory, the standard doesn't go into a huge amount of detail on that because that often is, that's often more about the kind of the ethics, I think, of AI in terms of how much information should an AI model have access to, and so and how is that information acquired? So this standard itself, its parameters are purely on the security of AI systems. So making sure that that data itself has come from secure places and it's treated securely, but not necessarily about whether the you know, how much data is actually coming in or coming out necessarily, as that is, I think, my understanding is that's more to do with the kind of the ethics of how you use data, which I think there are other standards going on that are being developed at the moment on actually how that should be. Does that answer your question? I don't. Somewhat. We can talk about it maybe at the end if that's helpful.
Hi. Thanks for your presentation. I wanted to understand the process of developing the standards, particularly from the fact that you must be working with different jurisdictional bodies and different regulators altogether. I think the fact which pretty much boils down to regulations and standards when they are in the development process is how stringent or how flexible you can make, so that it is easier to navigate for multi-jurisdictional organizations or entities. So I wanted to understand what kind of different standard bodies and regulatory bodies did you connect with whilst developing the framework that you did?
Yeah, really good question. So in terms of the regulatory part of that question, because generally, as I said, the UK government tends to see standards work as a voluntary thing. So for us, we focused our efforts more about just making sure that this standard was voluntary. Now, if other countries decide that they want to take this standard or any other standard and turn it into regulation, then that is entirely up to them. The UK government currently is not looking to do that. Doesn't mean that, you know, the Indian government won't do that, or the French government, or whoever. So in terms of the regulation question, the only thing we touched on really that was kind of linked to it was on the EU AI Act. Because the EU AI Act is a kind of form of regulation somewhat. And so that's why we then upgraded it from a TS to an EN to just ensure that we were meeting within the EU framework. As far as I'm aware, the EU AI Act is not quite, like there aren't similar kind of requirements in other jurisdictions across the world. I know, to be fair, other countries are thinking about this and trying to work out, and that is probably that will be an area we will need to look into a little bit more if different jurisdictions end up taking a similar route to the EU. In terms of working with just other jurisdictions, you know, in making sure that the standard was applicable, we worked with a whole range of different countries across Europe and outside of Europe, and we have been in constant contact with Senelec, which is the European standards body for the kind of that takes a primacy on the EU AI Act, but then also ISO as well. So ISO, obviously, you know, every country feeds into ISO. India, as part of the Indian National Standards Body, feed into ISO as well. And so we've been collaborating with them to make sure that the work we are doing does not duplicate or contradict the work that ISO is also doing, but actually, if anything, complements it. So the different standards experts that are working in ISO are checking to make sure that what we are doing is not causing any issues from their work, but also is just a good quality standard. And we're doing the same thing, making sure that actually the work we're doing is complementing their work as well. So we like to think that we have been trying to talk to every single person, and it is a competitive field. You know, developing standards in AI is a competitive field, but we like to think that we are kind of making sure that we are providing complementary work. Okay. Any more questions? I think I'm probably at time, but I'm happy to speak to people at the end if there are any kind of further questions. Thank you very much.